Okay, for the next example, it's going to have no diagram, so we'll have to draw the picture ourselves. Brian's kite is flying above a field at the end of 65 meters of string. The angle of elevation to the kite measures 70 degrees. How high is the kite above Brian's head? So here's our kite. This can be our string, 65 meters. Here will be the right triangle. This is the angle of elevation to the kite is 70 degrees. And we want to know how high the kite is off the ground. So we're looking for x. So from our reference angle 70, we have opposite and hypotenuse. So we're going to use the trig function sine. So sine of 70 degrees is equal to sum height over 65 meters. Cross multiply. And x is isolated. So now we'll just use our calculator. And we have 65 times sine of 70 degrees. And it's 61.08. So we'll just say x is about 61, and this is meters. From an airplane at an altitude of 1,200 meters, the angle of depression to a building on the ground measures 28 degrees. Find the distance from the plane to the building. So if this is the airplane and the altitude is 1,200 meters, and then we have some building over here. So the angle of depression is this angle outside of our right triangle. It measures 28 degrees. We want to know how far the plane is to the building, this distance right here. So again, we can subtract 28 from 90 and use this as a reference point, or we can identify that this angle, 28, and this angle here are congruent because they're alternate interior. And so I'm just going to use this as our reference angle. And we're looking for x here. So we have opposite and adjacent. So that's going to be tangent. So the tangent of 28 is equal to 1,200 over x. We're going to cross multiply. We're going to isolate x. So x, the distant x is going to be 1,200 over the tangent of 28. Divided by tangent of 28 degrees is 2,256, about 0.9, and that's meters. So I got 2,256.9 meters. Okay. A 14-foot ladder is used to scale a 13-foot wall. So let's see. We have a wall that's 13 feet, and we're going to have a ladder that's 14 feet. At what angle of elevation? So angle of elevation is going to be inside our triangle. That's this angle here. We need to know what angle of elevation must the ladder be situated in order to reach the top of the wall. So we are looking for the angle this time. So my reference point, or reference angle x, we have opposite and hypotenuse. So that's going to be sine. So the sine of some angle measurement is equal to 13 over 14. So we're going to use the inverse trig functions. And x is going to be equal to the inverse of sine over 13 over 14. So second sine, use your n over d feature, 13 over 14, and we get about 68.2. So we will just round to the nearest degree, so 68 degrees. An airplane takes off 200 yards from a 60-foot building. At what angle of elevation must the plane take off in order to avoid the crash? So the airplane's on the ground. Here's our building. So from here to here is 200 yards. And our building is 60 feet. So we have two different units. So we need to convert these. So we can just, there are 3 feet in a yard. So I'm just going to convert it all to feet. So we're going to use 600 feet here instead of the yards because we have to have the same units. At what angle of elevation? So that's inside our right triangle. So at what angle of elevation must the plane take off in order to avoid crashing into the building? So this is our reference angle. We have opposite and we have the adjacent, so that's tangent. So the tangent of some angle measurement is equal to 60 over 600. So we're going to take the inverse of tangent on both sides. And now x is isolated. Inverse tangent. This is 5.7. That's a little silly, but the angle measurement is, we'll say 5.7. We'll round to the nearest degree, 6 degrees.